One of the most frequent misconceptions children and adults have about geometry is the square versus rectangle argument. Rectangles are quadrilaterals, which are four-sided polygons, and a polygon is a closed figure with straight sides. So a rectangle is a quadrilateral that has two sets of parallel sides and four right angles. So if you think about that, a square also has opposite sides are parallel and there's four right angles. So the addition of one more criteria makes it a square, and that is that all the sides are equal, or congruent. The sides are the same length, and that makes a, a shape a square and a rectangle and a quadrilateral and even a rhombus. Um, the definition of a rhombus is a quadrilateral with two sets of parallel sides. So rectangles are rhombi and squares are rhombi as well. On this slide, the yellow figure is the rhombus, and I'm saying rhombi, R-H-O-M-B-I, which is the plural of rhombus. And then trapezoids in math world have two different definitions, and sometimes there's just decisions that are made by mathematicians. For instance, the order of operations is just something that mathematicians around the world decided, okay, this is what we're going to do. So the trapezoid issue has two different definitions and they're both correct. So what you have to do is find out what the testing that the state is involved with. Like last year it was the park testing. In North Carolina, Kitty and I had to decide what definition we were going to use. We decided on there's only being one set of parallel sides, which the green shape then would be the only trapezoid, whereas the other definition is at least one set of parallel sides, which means that then all of these shapes are trapezoids in addition to being rectangles and rhombi. So that's the issues there. The next issue to talk about is that a lot of times kids will see only the examples of figures that are the regular figures, and regular has a specific definition in geometry. A regular figure is one that all the sides are the same length and the angles are the same size. They're congruent. So on this page, the blue figures here are there's regular hexagon, regular triangle, and regular pentagon. And a lot of times kids think that those are the only shapes that are those names. So they would not name these figures in purple as being hexagons, triangles, or pentagons. Some of this comes from them only seeing shapes in pattern blocks or other manipulatives, and just not having seen other shapes that have that many sides. So a hexagon is any polygon with 6 sides. Okay, remember, a polygon is a closed figure with straight sides. So a polygon with 6 sides is a hexagon. So all 3 of those are polygons. I mean, hexagons. Yeah, I was just checking that last one there. So the last 2 have concave angles to them, which make them kind of interesting. That angle that goes in like a cave is how I remember concave. The other angles are convex. They're the ones that go out. So the blue hexagon has only convex angles, and the 2 purple hexagons have one concave angle, which is just an interesting little aside. Kids find that fascinating and enjoy talking about that. Even my second graders learn that stuff. Um, so we need to make sure that students see lots of variations of hexagon of all shapes that we name. Even quadrilaterals are not just rectangles or squares or even just trapezoids and rhombi. They come in all different shapes and variations. Um, One of the problems with geometry is it has so much vocabulary and terms like regular and um, oh shapes and just so many words that are just used in common everyday language have specific definitions in geometry, and so that can cause problems, particularly at testing time when they're faced with having to read a problem and understand it, and the problem's using the math vocabulary and they're not used to it. One of my embarrassing classroom stories that I tell fairly often, um, our end of grade test was the state test at the end of the year, and I had fourth graders, and um, in the middle of the test, one of my students raised her hand, little girl raised her hand, and I went over and she pointed to a word and said, "I don't know this word." And the word was congruent. And um, of course, I couldn't say, "We've been using that word since the first day of school." Um, just do the best you can, honey. And so I, thought I learned my lesson. The very next year, again, a student raised their hand in the middle of the test and pointed at the word congruent and said, "I don't know this word." So I realized, okay, just saying it and having them use the word is not enough. They have to see it so they can read it and write it as well. So that's when I started doing a math word wall. So your math word wall is separate from your high frequency word wall. Your high frequency word wall has the alphabet, and then you add words under each letter as they come up, as they arise. Generally, you should be using words that students are actually using in their writing and that they're misspelling. Um, and that content vocabulary shouldn't go on that high frequency word wall. It should have a separate bulletin board or something, so you can have your science word bulletin board, your ecosystems bulletin board, or whatever. And math words are kind of similar. They need to be separate. They need to be all together and added to the they come across these words in class. Now, of course, you're going to plan that these words come up in class, but I just, I taught back in the day of the overhead projector, and I had my overhead projector on a cart, and I had, many different things on my cart that were tools for different things. So I had sentence strip paper in different colors, um, and so whenever a word came up, oh, vertices, that's a great word we need to add to our word wall. So I'd write out the word, snip the paper off, and tape it up to the wall. So it just became a collection of words. They don't have to be organized by alphabetically. But once I just kind of started at the corner of my bulletin board, and then as time went on, the words went out, up and out, so that ended up being kind of a clump around the end of the bulletin board. But kids know that the time, oh, that's a word that we just learned, so it's going to be out towards the edges, kind of thing. Use color. you can, I never got around to making this happen, but you can put like your geometry words in green and your, base 10 words in yellow and things like that. So you can organize the words by content area and their color. I just did it by random. But not only do you have to have the words up there, but you have to have activities that kids do so that they're drawn to that word wall at least once a week, and usually more like 2 or 3 times a week. So little activities as you're starting your math class, um, things like dictation. Okay, number your paper 1 to 5. Now write the sentence, and if you need to use the word wall, then you look up there. A triangle has 3 vertices, and then they need to write the sentence. A triangle has 3 vertices. So knowing that triangle and vertices are words on the word wall. You can have them make sentences. Your word for number 2 is trapezoid. So write a sentence with the word trapezoid. So they might need to write the sentence themselves. You can do bingo kind of activities. They call it Wordo or something like that. Just have blank 5x5 grids, and I I made every kid keep up with their own chart, and so it just went in their math folder. So when we did it, of course there had to be 25 words up on the word wall by that time, so you can't do it the first week of school. But you say the definition of the word, and then they can cover up if they've got it on their paper. So what I did was every time that we pulled out the wordo thing, they had to erase 3 of the words that they had on their chart and add some of our new words. So it kind of kept their chart changing. Make sure they use pencil to be able to do that though. So those are some activities that you can do to get them looking up at the word wall frequently, so that they're reading and writing those words. As the 4th item here, as you're talking about the math and shapes, particularly, you're saying, okay, here's a shape. You've got one on the smartboard or whatever. How many vertices or corners does it have? And so at the beginning, you might even say how many corners or vertices, that's the official word, is vertices, does it have? And so combine the corners and vertices together, then say vertices or corners, and then after a while you're going to start dropping, how many vertices does it have? Who remembers what vertices are? Okay, yes, they're corners. Good job. All right, how many vertices does this have? So that you're combining the common vocabulary with the technical vocabulary. That's kind of scaffolding for them. And then I told you my story about the congruence. So the children need to be able to read it and write it. Now my master's is in literacy, and Jim Cunningham was my professor, no relation to me, and I actually changed my name after I graduated so it didn't look weird that I was Cunningham in the middle of my master's program. But anyway, he used to always say, if they can read it, they can't necessarily write it, but if they can write it, they can read it. And that really is the logic behind the high frequency word walls. So anyway, there's my little lecture on vocabulary. Our last slide is about 2D versus 3D in geometry, and I never had the situation where I had kids calling a cube a square, and that may be because I had older children My children generally were second through fifth grade. Um, but I can see where that would happen, where particularly in this age of worksheets, where the 3D drawing may be on the paper, but it's still flat, and kids not recognize the difference in the 3D drawing versus a two-dimensional drawing of just a square. So we need to be careful about that. We need to make sure that we're having kids hold 3D shapes. Um, there's great wooden shapes that are out there now. There's, Didax.com is a good supplier of those materials. But making sure that kids understand that a 3D shape is something that you can have and hold, and that a two-dimensional shape is just a drawing on the paper. So I never really had that problem like they discussed in the Math Misconceptions book, but we can talk about, like it talks about in there, about the rectangle, uh, a file cabinet being referred to as a rectangle when it's actually a rectangular prism. We can talk about the face of the rectangle, the rectangular prism is a rectangle. And to help kids realize that when we're looking at the file cabinet, we're just looking at this side is a rectangle, or just the front is a rectangle, but that this is a three-dimensional shape, which is a rectangular prism. And so labeling, that, you know how you label things around the room, labeling items around the room, use sentence strip paper and just, rectangular prism, or this face is a rectangle. I think we need to make sure that we're aware of that when we talk about geometry and geometric shapes with young children. Okay.